Hello everyone, I am Supraja from Sai Vidya Institute of Technology. This is the video demonstration for Texas Instruments Analog Design Contest.
Radio beacon is an electronic navigation instrument which consists of a self-contained radio transmitter and is useful in Corpus SARSAT system to provide distress alert along with location data for search and rescue. It is one which provides aids to surface navigation for ships and aircrafts. It will provide good range and better accuracy. Types of radio beacon include emergency position indicator beacon, emergency locator transmitter, and personal locator beacon. Marine ships use EPIRB, aircraft use ELT, and PLB is used by people taking part in land activities such as hiking. The various components used in this project are TI's MSP430 processor, temperature sensor LM35CA2, which was sponsored by TI, pressure level sensor, water level sensor, buzzer, GPS, LCD, battery, solar panel for charging circuit, and various regulator ICs like IC7805, LM317, LM324, comparator IC, NHD12D, NHD12E decoder, encoder, and 433 MHz and 314 MHz transmitter receiver pairs. The MSP430 is the central unit of a transmitter. It is powered by a solar panel via a charging unit. A 12-volt rechargeable battery is used as backup power source. The various sensors such as water, pressure, and temperature sensors are connected to the MSP430. The MSP430 is programmed to raise an alert when the sensor data is above a threshold. The signal is encoded and transmitted via transmitter. A GPS locator is used for position location. The circuit uses a solar-powered battery power supply. During daytime, the battery charges through resistor R1 and diode D1. This charging mode of the battery is indicated by a glowing green LED. During night time, current from the solar cell decreases and D1 is reverse biased. At the same time, D2 is forward biased, providing power to the circuit. Resistor R1 restricts the charging current and the high value of capacitor C1 acts as a buffer for current. The diode used is IN4007 and the capacitor is 2500 microfarad. The final output from the transmitter section is sent to the transceiver section, which acts as a satellite model. In this model, the satellite is used as a medium for sending the signal from the beacon to the destination for its rescue operation. The received signal is decoded and the MSP430 processes this signal. The buzzer indicates that a signal is received. A personal computer is used to indicate the position of the transmitter using maps via a PC interface circuit. The beacon transmits the distress alert to a satellite. The satellite locates the beacon position and transmits this information to a land station, which in turn transmits the information to the Rescue Coordination Center. Beacon's operating frequency is 433 MHz. It has a hydrostatic release unit which is released when the vessel sinks. The beacon device emerges on the surface of water and starts to transmit distress alert.
This is the exact working of the beacon device when it is put under distress. Now let us see the working prototype of our Horfunk beacon project. As you can see, all the connections are made to the beacon device where the components are connected to the MSP430 processor. All these are actually placed inside the Horfunk beacon device. Now let me run you through all the components in the Horfunk beacon device. This is the pressure sensor.
This is the water level sensor. The buzzer to indicate the distress signal. The temperature sensor. The auto manual switch. And the transmitter.
Now let us see the working of the temperature sensor. When the temperature sensor is kept near the candle, the buzzer is turned on and the distress signal is transmitted. Similar way like the pressure sensor, the automatic switch also sends a distress signal to the rescue station if all the other sensors fail. This is the water level sensor. When it is dipped into the water, after a certain threshold, this part moves up. When it reaches the top, the buzzer sound is produced. The signal gets transmitted. This is a college blueprint, which is considered to be a rescue station, and thus the receiver is kept, which is connected to the 4 LEDs, which indicates the canteen, the library, the principal's chamber, and the classroom. This is an example how a rescue station would work if the beacon device transmits a distress signal. One of our teammates is in the ground floor library and the others are monitoring the rescue station. Similar way like the pressure sensor, the auto manual switch also sends a distress signal to the rescue station if all the other sensors fail.
On the top we have the temperature sensor, next to that the auto manual switch. On the left hand corner we have the water sensor. The right hand corner we have the pressure sensor. Below that we have the solar panel, which is charged externally by the charging circuit. Below that we have the battery. It is powered by the MSB 430 processor. Below that we have the transmitter.